All right, today I'm going to do a quick tutorial on how to graph a piecewise function. We're essentially going to graph both of these lines on the same piece of graph paper. I'm going to actually do it over here, so kind of just ignore that little piece of graph paper. And I'm going to split this graph where x is less than or equal to 2 and x is greater than 2. So I'm going to have a line graphed in this section. I'm going to have that negative 2x minus 1 over on this side of my graph paper. And on this side of my graph paper is going to be the line negative x plus 4. I would suggest to do this all in pencil just so that you are able to erase lines when needed. So in pencil, I'm going to start by graphing this line. My slope is -2. My y-intercept is -1. So I'm going to start at -1 and make a nice big dot. My slope is -2. I often consider that -2 over 1, where I'm going to go down 2 and to the right 1, or I could go up 2 and to the left 1. So I'm going to go down 2 and to the right 1, down 2 and to the right 1. I'm going to continue as far as I can go all the way across my paper. Up 2 and to the left 1, up 2 and to the left 1. Again, as far as I can go. So it covers the whole paper. However, this line should only exist where x is less than or equal to 2. So at this point where x equals 2, I want my graph to stop. So here we are where x equals 2. This is where my graph should stop. And I'm going to erase the rest of that line. This function negative 2x minus 1 does not exist beyond this point. My negative 2x minus 1 stops here. What I am going to do next is figure out the other part of my graph paper where negative x plus 4. I have to start graphing on this y-axis. However, I'm going to erase everything that is over on this side of my graph paper. I'm going to keep everything on that side. So again, here we are. My slope is actually -1 over 1. So again, I'm going down and to the right or up and to the left. I'm going to start at +4 on my y-axis. I'm still going to start here on my y-axis. I just know I'm going to erase this part. But down 1 to the right 1, down and to the right 1, down and to the right 1, down and to the right 1. And I'm going to draw that line all the way through. Now, I have to figure out where this actually starts. It's supposed to start where x is greater than 2. And so if I'm at 2, it's supposed to start right here at this point. Everything else before that, I'm going to erase so that everything on this half of my graph is my first line. Everything on the second half of my graph is my second line. The only last thing I want to note is that this is a less than or equal to symbol. That's a closed circle. Whereas this is x is greater than or equal to, that's an open circle. So this is an open circle where I don't have anything inside of it. I might even want to erase what's inside of it. And this is a closed circle. Closed versus open. All right, let's try another one. Down below, again, I have these two different graphs. One that's +2x plus 1, -2x plus 3. the split happening on my piecewise function is happening at +1. So here at +1, I'm going to have my split. This side of my graph is going to be everything x is less than 1 is going to be this 2x plus 1 part. Oh goodness, that's backwards. Negative 2x plus 3. And everything less than 1 is the 2x plus 1 part. There they're on. So those are my 2 halves of my piecewise function. We're going to graph this line like normal. I have my slope, I have my y-intercept. So let's go ahead and graph it. I start at 1. My slope is 2, so I'm going up and to the right. If I need to fill up my graph, I'll go down and to the left. So up 2 into the right 1, up 2 into the right 1, up 2 into the right 1. But I'm probably going to need to fill up my whole graph. So I need to also start back at the y-intercept, go down 2 into the right 1. I'll make my whole line. However, I need to stop where x is 1. I want everything less than x equals 1. So I should have a starting point right here at x is 1. This is where my graph is. It should be an open circle. So let me erase that and make it an open circle. And I'm going to erase everything else over on this side of my graph paper because this side of my graph paper is my other function. Negative 2x plus 3 is going to be over here. So let's start graphing this line. My y-intercept is +3. Again, I have to go back to my y-intercept. I'm at 3 here. And my slope, -2, I'm going down and to the right or up and to the left. Either way I think about it. So down and to the right, down 2 into the right 1, down 2 into the right 1, down 2 into the right 1, and I'll just keep going that way for the rest of my graph paper. And I can draw that line all the way through. However, I know that my starting point should be at x is greater than or equal to 1. So here at 1, I'm 1 point above that. That's going to be a nice closed circle. And I'm going to erase this part of my graph that's over here. This is where I start. And then I continue the rest of the way down. Those are your 2 examples. The last example I want to show is actually on the back page. When we are asked to find the value, I'm going to be plugging these values into this function. The first question is to ask which function does that fall under? So at f of 3, 3 is greater than -2. So f of 3 is going to be in this function. At f of 3, it equals -4. That's my answer. F of -4 actually falls into this function because f of -4 is less than -2. So I'm going to plug -4 into that function. -4 plus 5, f of -4 is 1. F of -2, it equals -2. We're going to fall into this function down here. So my answer is -4. If I were to go down to this next spot, the function that we actually just solved for, f of -2, is -2 less than 1 or greater than 1? It's less than. And so I'm going to plug -2 into x in that equation. 2 times -2 is -4, plus 1 is -3. Now 6. Is 6 less than 1 or greater than 1? And it's greater than 1, so we're going to use that second function. I'm going to put a 6 in the x spot. -2 times 6 plus 3. I have -12 plus 3, which is -9. And f of 1 is 1 greater than 1 or less than 1. It's actually equal to. I'm going to go to the equal to spot. F of 1, I'm going to plug a 1 into the x right there. -2 times 1 plus 3. So I'm at -2 plus 3, which equals +1. And if you go back to this graph at f of 1, we have a closed circle at +1 because that function, we're starting that function and that function lands right there. So there it comes full circle.